Okay, can you hear me now? Okay. Awesome. Yes. All right. Good afternoon, everyone. How is everybody doing? Okay, no replies. No. All right. Are there any questions that I can answer to begin with? Okay. So, last week on Thursday, yeah, that's where we stopped. I think, from what I vaguely remember, we kind of like rushed it at the beginning, and I just threw endmap and ormap at you, like here are two functions that are predefined for you and abstract another recurring pattern of behavior of functions of a list. So I'll do a quick recap of what nmap and ormap do and why we use them, and we'll do a little exercise in using them to define functions. So the first of them, nmap, basically abstracts the pattern where you kind of want to check that every element in a given list satisfies some condition, right? You want to go through the whole list and check that every element in the list satisfies a given condition. And for this reason, whenever we have an empty list, basically the convention is to say that any condition is satisfied by an empty list. Because the question that you are asking, for any element that I can find in the list, does this condition hold? If I cannot find any element, we say, well, it holds, because for any element that I can find in the list, it holds. I just happen to be not able to find any elements. So that's one reason why we use true in the base case of these functions, right? So in this case, every number in an empty list is positive. It's also negative. It's whatever you want it to be. It's an empty list. The second reason is because of the operator that we use in the recursive case, right? So if we used false in the base case, then whatever work we do in the recursion during kind of going through the list would be annihilated by the time we get to the false. So anything that was true before becomes false. But basically, the pattern is true for the empty case. If we do have some elements in the list, check the first element. If it satisfies the condition, then we still might have a list that returns for which these conditions hold. So if this is true, then we'll check whether the rest of the list satisfies the condition. So in this case, it's basically checking whether all numbers are positive, right? The nice kind of side effect or feature of AND is if we find one element that doesn't satisfy this condition, we actually stop checking completely, right? Because if you remember, AND has the short-circuiting behavior, where as soon as we have a false in the first argument, we know that we need to return false. So there's no reason to even try to evaluate this. Okay, so the function written this way actually has the nice side effect that as soon as we find some element that fails this test that we are giving it, we stop and return false. Okay, so that's one pattern. And to abstract this, the ISL library provides, let me put this onto one screen. ISL provides an abstraction called nmap, which takes in a predicate, right, that takes in an element of the list. So we say, if we have an element of an arbitrary type, a list of elements of arbitrary type. We give each element to the predicate, and again, if the predicate is satisfied by the element, we still check the rest of the list, so we combine it using n. For the empty list, we return true, right? So the point here is that whatever we are checking, whatever the test inside our function is, we need to be able to abstract it as a predicate to pass in, right? Something that you can ask of each element, do you satisfy this? Is this true for you? And while it's true, we return true. If there's at least one element that falsifies this, we return false, okay? Does this pattern and nmap and this recursion pattern make sense? Yeah, I don't want to dwell on it for too long. We don't have to. Conversely, if we are trying to ask if there is some element that satisfies a given condition, right? We are looking for at least one element that satisfies some condition. We basically have a very similar pattern. The difference that happens though is we use OR to combine. So we check, like, does the first element satisfy, or the second element, or the third one, or the last one, etc. In the base case, again, we flip what we check for. So instead of true, we use false. Because the convention there is, if I have an empty list and I'm looking for at least one element that satisfies the condition, then I have no element, okay? And I return false. And it just so happens that returning false in the base case is what makes this recursion pattern work. Okay, and again, useful common pattern. We have an abstraction for this provided by ISL, where we pass in a predicate and it checks whether there's at least one element that satisfies this. Okay. Any questions about this? OR map, and map. Okay. Any ideas why these are called AND map and OR map? Yeah, Pearl? Yeah, they use AND and OR operator. Where does the map come from? Yeah?
Map applies some function to each element in the list used. Basically, what's in this case, we're applying AND or to each element or each element of the list.
Yeah, exactly. So what is actually happening here is that we are mapping the predicate onto each element. Although we do use the short-circuiting behavior, but in theory we are mapping the predicate on each element. So we are taking a list of an arbitrary type, converting it into a Boolean. If all the Booleans are true, then nmap is true. If all the Booleans, if at least one Boolean is false, then the whole thing is false. For OR map, again, you can think of it as mapping the predicate over the whole list. And if at least one Boolean in that list is true, then the OR map will return true. If they are all false, then the whole thing is false. Okay, so that's why it's OR map. Map the predicate and combine with OR AND. Okay, let's do a little exercise here. So let's say that I want to, I'm writing a function that checks whether all the strings in a given list are of length 2. Okay, so I have a few checking specs there. The thing that's left, apart from actually the signature, right? So all 2 strings takes in a list of string and returns a Boolean. So how can I define this function? feel free to either apply the list template or use nmap or ormap. Yeah?
So would we create a predicate for like that the string is selected to?
Okay, so if we want to use an nmap or an ormap, we need to abstract what we are checking, right? The condition that we are actually checking is that a string is its length of the string is greater than, no, equal to 2. Right? That's what we are trying to check. So if we want to use one of our abstractions, we need to define a function that checks, let me give it some name, takes in a string and returns a Boolean. And let's call it is 2 or equals 2. Okay, define 2 for some string, and I'll just say string okay. How do I use this predicate now? Josh?
You can say
Endmap, what was that?
nmap is the name of the predicate.
Yeah, length equals 2 and the list. Okay. If I were to type it all out, I can actually, if I copy this, what I get here is a string length first 2 is 2 and okay, so that's the alternative definition that you would get if you just plugged everything into Nmap. Just to compare. Okay, how easy is it to now define one that checks if there is at least one string that's 2 characters long? Yeah?
Format
Yep.
has string equals
Uh-huh. Length equals 2 and L. Okay. Really easy. Just flip the predicate. Let me check how many typos I introduced. And we seem to be good. Okay. So let's see, get them here. Any questions? Okay. Or anything like my morning section, I will go on and then get a section, a question about this like 10 minutes later. Yeah, Carlo?
Why is it returning true?
Why is what returning true?
All two true.
Because what we are actually asking of this list is every string that's in this list 2 characters long, right? If we cannot find any string in the list, then it is still true that every string in that list is 2 characters long because it's empty. Basically, you look into the list and it's like, is every string that I can find? So if I can find something in the list, is it 2 characters long? Okay. There is a logical reason why this is the case. If it helps, you can just think of it, well, this is what makes the recursion work, as opposed to returning false in that case. But there is a logical reason why this is true, why the empty case is true. Okay. Any other questions? All right. Let's do another kind of abstraction. So I want to define the following function. Design a function that that keeps the odd numbers in the given list of numbers. Okay, so what I'm trying to do here, let me write some examples, and I will call the function keep odds, and I will give it 1, 2, 3, 4, 5, 6, 7, 8. Okay, and from this list I want to only keep the odd numbers. If my list only contains odd numbers already, then we should get the same thing. And for a list that doesn't contain any odd numbers, we want to get nothing, right? Those are the extreme cases, and of course for if we have an empty list, we also expect an empty list. There are no odd numbers to keep. Okay. Okay, what will be the signature of this function? Josh? So it will take in a list of numbers, and it will also output a list of numbers. Okay. Here from the signature. Now, how do we define this function? Yeah?
We could do the filter. Okay, we could, we could make a con.
Yep.
And then for the empty case, we could just output case.
Okay, so if it's already empty, we return empty, which is given by the check expect. For the cons case,
We can check odd, the first element.
okay, so if the first element is odd,
Then we output, we make a, yeah,
yeah?
So we do cons,
Mm-hmm.
first element, and then we keep odds of the rest of the element.
Keep odds of the rest of the element.
Else we just do keep odds of the rest of the element.
Otherwise, what was that?
We just keep odds
We keep the odds
of the rest of the element.
from the rest of the list.
Also on the note, couldn't we just filter odd non-element?
That's where we are getting to. Okay, so if we are writing this function following the list template, this is what we end up with. If the list is already empty, we just return the empty list, right? There's nothing to keep in there. if we do have an element in front of a list, we check if the element is odd. If it's odd, we cons it, so we keep it in the front and still try to keep the odds in the rest of the list, right? If it's not odd, we still need to go through the rest of the list and keep the odds in there. But we discard the first element. We just throw it away, forget about it. Okay. If it's odd, keep it in the front, keep odds in the rest of the list. If it's not odd, so if it's even, still keep the odds in the rest of the list. Okay. I see a few frowning faces. What questions are on your minds? Anything that doesn't make sense? Okay. Now, if we flip it, and some of you know where we are going with this, if I want to do the opposite and I want to keep the evens, right? So if I want to keep the evens in this list, of course need to fix my examples. 2, 4, 6, 8. Here we have no even numbers, so we get empty. If we have only even numbers, we get the list itself back. Right? Now, this is pretty obviously pretty much the same function. The only thing where it really differs, apart from the name, is what I'm using to check the predicate, right? Whereas before I kept the odd number, so whenever I found an odd number, I kept it and kept the rest. If I found an even number, I didn't keep it. I got rid of it and kept the rest. In this case, I simply switched to checking even, right? And I have pretty much the same function otherwise. Okay. So to get to where everybody knows we're going, let us abstract this into a function that I will call keepIf for now, right? And I want it to be general enough, so I'll get a function that for an arbitrary element, will return me true or false, so similar to Nmap. I'll give it the list of those elements, and we'll return a list of those elements, right? And to abstract these, so we identified that the thing that changes in there is the actual predicate that I'm checking for each element of the list, right? So the even or the odd, which is the function that takes in some element and returns a Boolean. So I need to abstract that, just like we did with Nmap and Normap. Otherwise, I'll do the same stuff as before. Yeah? What did I forget? Yeah? Right. Takes an extra argument. So I need to pass it along. Now, how do I define my keep odds of a list of number and keep evens of a list of number using keep if? Max?
So keep on will be keep if on
Keep if odd LON, right? So I keep them if they are odd, each element of the list of numbers. The even one, yep. Keep if even LON. Rerun to check that we didn't break anything, and we're good. Okay. So again, another process of writing down the function for particular conditions, abstracting the common pattern into a generic function, right? That doesn't care about the kind of arguments and doesn't care about the actual condition that we are checking. Redefining the original functions, checking that they still satisfy. Yes? Can you speak louder?
Why do we need a predicate in the last line?
Over here? So, since we abstracted the predicate and made it into an argument of the function, right? We need to pass it in when we do the recursive call because it's still the same predicate that we are checking for the rest of the list, right? Here we only want the elements from the list that satisfy this predicate so that we can return it further up. That makes sense. So we need to pass in the predicate. Simple answer is that our function now takes two arguments and we need to pass them along as we go down. Any other questions? Well, and as quite a few of you know already, what we define here is a library function that's called filter. Okay, so this is exactly defined. It's called filter, has exactly the same signature. Takes in a predicate, which can check each element for whether it holds or doesn't hold, returns a list that filters out only the elements that satisfy the predicate. And I can use it in place of my keep if function. Okay, filter is defined exactly the same. Okay, let's do an exercise with filter, and let's design a function that takes a list of numbers and returns list of numbers and a range, and returns the numbers which are in the range. Okay, so I want the function, let me write some examples, that keep in range, give it a lower bound and an upper bound, and the list okay, and it gets rid of all the elements that are not in the range. So we should get 1, 3, and 5. Okay. About some other examples. 20, 10, and 15 in the range there. Okay. So get a range, get a list, return only the numbers that are within the range, including the bounds. And let's define this. So we have a lower bound, higher bound, and a list of numbers. Signature will be list of returning a list of number. Yeah? So this X is actually important to put in there. There's nothing in Dr. Racket right now that will bite you if you don't put it there. What it says is that we actually mean a variable X rather than some type. If I removed it from there and somebody defined the type called X before, then this function would refer to that type. Here we say this is an arbitrary X. It just needs to be consistent across here, okay? The way you can also think about this is that this is a function that generates signatures for you, right? I can plug in number and each X will be replaced by number.
And then don't use the low and the high with
Can you use
the low and the high, because those number and two numbers.
low, high, which one?
In the signature, it says list of numbers.
Oh yeah, of course, thank you. Thanks. Any other mistakes that I made? Yeah.
Oh, there's a question.
Oh, there's a question. Is filter an ISL defined function that we made using keybif? Filter is an ISL predefined function. So filter is predefined in the library. I didn't define it, but filter. It is predefined in ISL. Okay, so you can use it just like Foldar, Nmap, ORMAP, map. Filter is also a function that comes with ISL. Okay, any other questions about the function that we are currently defining? Okay, now the big question is, how do we define this? Max?
Can we do a local function?
Okay, so,
Because
yeah?
when we do filter, we need a predicate, so we need to make the predicate using the numbers that we put in the general filter.
Okay, so if we want to use filter, filter takes 1, 2 arguments, right? We know we are filtering a list of numbers, so that has the type list of number. Here we need to pass in something that returns a Boolean, right? And because we are passing in a number, it needs to take a number and return a Boolean, right? So we need a function that will check whether a given number is within the range, right? And as Max pointed out, we need to do this via a local definition, which we put here. Okay. Why cannot we do it as a global definition? Yeah?
Is it because the parameters low and high are like in key range, so you have to use them somewhere within the actual definition?
Yeah, exactly. So the number that we are comparing, so the two numbers that we are comparing in relation to are the low and high range, low and high boundaries of the range. If we decided to define it outside, right, as a function, we would get into the problem where we would say, okay, how does it relate to high and low? And we would run into trouble. Okay, where does high and low come from? We need to put them as argument, but then again, we wouldn't have a function that fits the signature. Okay, so this is the reason why we need to define this predicate in here. Let's call it in range for some number n. Okay, how do we define this function? Yeah?
We just like string them up, not string them, but you have like greater than or equal.
Greater than or equal?
Or would be less. Oh, it doesn't matter.
You tell me.
You could just have high, then n, then low.
Yeah, exactly. So I can, let me write it down. So what I'm really checking is that n is, or low is either equal or less than n, right? And that n is less or equal to high. I want the number to be inside of the two bounds. And ISL, or all the student languages, actually allow me to express this conveniently simply by chaining this, right? So this says, is low less or equal to n, and is n less or equal to high? In mathematical notation, it would be low and high. Something like that. Okay. Now, let's plug in the function and see if it runs. And it runs. Okay. So again, the reason why we need a local definition here is that our in-range predicate needs to refer to the bounds that are passed into the function, but it still needs to only take one argument. Okay, so that's why we need to define this predicate somewhere where low and high are already available, so that we only need that additional argument. And so we cannot put it outside. We need to have it as a local definition. Yeah?
Excuse me, sorry.
No worries.
If we switched the numbers, like 20 and 10 in the objective specs, would we automatically turn like false? Or not?
So like this?
No, like in the, like instead of doing low, high,
Ah,
high, low.
yeah, so this would be an impossible range, right? Because we are looking for we are looking for a number that's between 20 and 10, right? That's lower than that's greater than 20, but also lower than 10, lower or equal. That's not possible. Okay. Go away. Hide yourself, please. Thank you. Any other questions? Okay, so now, together with local definitions, so that you can kind of change the number of arguments of functions, you have 5, I think, weapons that you can wield. You have foldar, which is the most general of them, right, which allows you to combine the elements of a list using some operation. We have map, simply allows us to map a function across all elements of a list. We have endmap and ormap, which allow us to check whether something holds for a list, and we have filter, which simply filters out elements from a list based on a predicate. Okay, and for the rest of this lecture, actually, and feel free to ask any questions about any of these. But for the rest of the lecture, I just want to go through a few exercises to practice using Foldar, because that's the one that's most general and usually raises the most eyebrows when you use it or how to use it. So let's start with some Foldar practice. We have a question online from Shai. Are these 5 what is meant by list abstractions in the HW? Yes, so these are the list abstractions. There are more list abstractions, so these are not the only list abstractions, okay? Okay, so just to remind ourselves, Foldar is a function that for any 2 types x and y, right, takes in a function, takes an x and takes a y and returns a y, right? So this is some operation that combines an x with a y, returning y. It takes what we call a base case, right, of type y. So this is what we return for empty lists. Then it takes a list of x and returns a y. And the idea is that we have a list of some elements and some base case, and we kind of summarize the list of x's into some value of type y. Let me remind us also how it works, because this is always a useful thing to recap. So if I have a base, if I have a function and I have a base and I have a list of things, an empty, right? If I apply Foldar to that list, what happens here is that I gradually, whenever I have a cons, I apply a function to this, to the element, to the first element, apply the function to the first element and the result of applying Foldar to the rest. So we can view it as replacing every cons application with an f application and the empty case with a base. Okay? And again, to just like really bring the point home, it's Foldar because we start combining from the right. Of course, we process the list from the left, but the result of this depends on the result of this, which depends on the result of this, which depends on the base. Once we have the base, we can combine the last element with the base, then we can combine the second element with it, and then we combine the first one at the very end. Okay. So that's Foldar schematically. And let's now use Foldar to design a function to compute the maximum grade in a list of grades. Okay, and we'll do a quick data definition here. We will say a grade is a non-negative number. So what we are defining here is a max grade. What's the signature for this function? Yeah?
List of grades or grade.
Yes, so we just take a list of grades and we return a single grade, which is the maximum grade. Okay. And let's do something like this. What is the maximum grade from these? Yep, 90. Awesome. And here we of course expect 10. Now the interesting question is, what is the maximum grade of an empty list? Something that we will have to decide, yeah? Sorry?
Just empty.
Empty. Yeah, we need to return a number, yeah? Yeah, we can just pick 0, right? Because we don't have any grades, and we agreed that a grade is a non-negative number, so something that starts from 0 and goes all the way up. So we can simply say that if we have no grades, the maximum grade from there is 0. Okay. Another way of handling this would be if we said, well, this should be a non-empty list of grades, and then we wouldn't have this case. We wouldn't have to worry about it. Okay, how do we grade, list of grades. And I definitely want to use folder for this one. Charlie?
Sure. So the first argument, we plug in the max function, and the second argument is 0.
Exactly.
Yeah. So 0 is our base case for when we have an empty list. Max just compares the two and returns one of the grades.
Mm-hmm. So because we decided that the empty case is 0, then that basically dictates what we pass in as the base case for folder. Then what we need here is to be able to just compare two numbers, right? Because combining two elements means just get me the maximum element of two elements. And we already have a function max for that predefined in the library. Let's just check that this actually behaves the way I wanted it to, and it does. Okay, let me just spend a little time with this. So let me take a subset of this. No, let's take a smaller one. So I have a list that has these grades, right? If I follow this schema here, what I'm actually calculating in the end is a max of 1 compared to the max of 50 and or compared to the max of 30 compared to the max of 2, right? Then we have the empty case, we give base. This is basically what we are computing. Yeah?
Regarding our choice of 0, is there ever a case in Dr. Randa where you use like a sentinel value like -1 to indicate that's an empty list for future?
So if there is ever a case where you would pick a 1 instead of 0?
1 as a sentinel value.
Oh, as a sentinel value. Definitely makes sense for some of these. The slight problem with using -1 for this case, right, is that it violates the type in here. So we would have to say, well, it's either a grade or -1. Then the question that we need to ask, why -1, right? And the question we would have to answer is that it's a dummy value, right? And in this case, we should probably return something else than -1 to signify that. Okay, so there's a little bit of like, do I consider -1 a grade now or not? So, but yeah, it's quite common actually still to use dummy values like that. But I would try to avoid it as much as possible and rather be very explicit, like this is something that's not expected, return false or something like that. Okay, but what I wanted to do here is that we start reducing from the right, right? So to compute each of these, we need to first compute the max of 2 and 0, which reduces to 2. Comparing 30 and 2 gives me 30. Comparing 50 and 30 gives me 50, right? And finally, 50 and 1 gives me 1. Okay, so that's the process of using FOLDAR here. Okay. What if I wanted the minimum grade? What would I need to do? How could I make it work? Max?
Same thing, just change min to max, min and folder.
Max to min? What's the problem with this one? Steven?
You need to change the base case because that will fall to 0.
Yeah, so we need to change the base case because in this case, if we use 0 as the base, then we always get 0, right? The grade is non-negative number. What do I change it to though? Yeah?
You just change it to 100 because the highest grade you could ever get is 100. So like if you had a list of all 100s, this one would still be 100. But if you had a list of like 100 and a bunch of other numbers that weren't 100, like below that, the grade can't go.
Okay.
Grade could go above 100, but
Yeah, but is there anything right now on the screen that warranties this? Yeah?
Since grade is specified as a non-negative number, it like theoretically go up to like 5,000.
There's nothing that, yeah, exactly. So there's nothing that we wrote down that actually justifies choosing 100 as the maximum grade, right? We could have grade with extra points and then it would be over 100. We didn't specify that. So if we nail down our data definition and said a grade is actually between 0 and 100, then we're perfectly fine with specifying 100. An alternative way is to make the function take a non-empty list, right? And then we can simply pick the first element of the list as the minimum grade, right? Because before we go into the list, any element, until we compare anything, the first element might as well be the minimum, right? So one has to think about what the possibilities are for the base case. Here we were perfectly fine with picking 0 for minimum because we said that 0 is actually, there's no grade that's lower than 0. Somebody gives us a negative grade, well, we don't guarantee for it to work. But if unless we specify that a grade is in the range from 0 to 100, we cannot simply arbitrarily pick one, right? Because we guarantee that it will work for a non-negative number, and it doesn't. Okay, so something to keep in mind. Okay, any other questions about this? Okay, slightly running out of time, so let's try to move on, and let's design a function which computes the length of any given list. Okay, so this function is as well predefined in ISL. I will call it myLength, right? And it should return a length of the list. So it should be a number. Actually, to be more specific, it will be a non-negative number. And actually, to be more specific, it will actually be a natural. Okay. What shall it take as input? Charlie?
Just a list of X anything.
Exactly. We don't really care what the elements of the list are. So we can take list of anything. Here are some check expects. 5 should give me 5. List. Give me 3. To demonstrate that this works for any list is, let's do some okay, so some strings, which is 1, 2, 3, 4 elements, and then of course an empty list should be 0. Okay, so I'll take in a list, and again, I'm very adamant about defining it using foldr, which gives us 3 arguments. Now, what do I plug in? Yeah?
Add 1, 0,
Okay, so we have add 1, 0, and L. How about this? Will this work? Charlie?
So the problem with this is if we look at the signature we wrote for foldr, it takes some function that takes an X and a Y and outputs Y.
Mm-hmm.
And add 1 only takes 1 argument. So we're going to have an error.
Yeah, so add 1 is a function that takes a number and returns a number. This is fine. This is a number, and this is a list of X, right? So what we expect here is actually, we have a list of X, so the function actually should take an X, then we are returning a number, so this fixes our Y and return a number, right? So we have a bit of a problem here with our function, which only takes 1 argument, which is the opposite problem that we usually had, right? Usually we had functions that take more arguments than we need to. Now we need to somehow get rid of 1. What shall we do? Any other takers want to tackle this problem? Some suggestions online. One hand up. Okay, so the suggestion that comes online is to create a local function. Right? Again, we have the case where we have a different number of arguments to the function that we actually want to use to what is expected. What do we define locally? So the suggestion is do a local definition. And define here. What do I define? Do you want to take it, Charlie?
Sure. Basically, we make a new function. We can call it anything we my add one list.
Okay. Add one
List.
list. Let's
And
call it that.
takes two arguments, X,
Mhm.
arbitrarily named X and Y.
Okay, X and Y.
And they represent the first and last in the list element. But anyways.
So, come again. So this one, what does Y represent?
So, if we think about what we passed to, or we're trying to pass to add one there,
Mm-hmm.
right? We have sort of the first and rest in the list.
Uh-huh.
And the first is whatever the type of our list, or whatever the type of our input list is.
Okay, so this is actually the element.
Yeah, and then the second argument is the calling of add one list on the rest of the list.
Uh-huh. So the way I would put it is it's actually the length so far,
Yeah.
right? So when we start with an empty list, the length so far is 0. So that's what we are plugging in. So I'll just call it length so far. Okay. What do we do inside?
We
Charlie?
it's just plus one length so far.
Length so far.
We ignore
Okay.
the
And we ignore the element. Okay, so if I plug this one in, now I have a function that takes some element that we even ignore and a number, and it's a number because we are adding 1 to it, and it returns a number. Because the result of adding a number to a number is a number. Okay, so let's see if this works. And it does. Okay, so we tackled the opposite problem. Instead of capturing some extra information that was around in the function, but we couldn't pass it when we were calling the function, we now need a function that has some arguments that we simply ignore, right? Because we don't care what the element is. We just need to know that it's there. And it's there because foldar calls this function when there is an element. Okay? Any questions? Charlie?
So for our racket style purposes, or as I preface this by saying, this doesn't have to be a local method. You can write it outside of this method and it will work just as well as if you write it inside.
Mm-hmm.
So for our style purposes in this class, should we do one or the other?
Excellent question. So, unlike the other functions, which had to capture some extra information that was flying around inside of the function, this one doesn't actually need anything that's outside of the function, right? It takes length so far as an argument. It takes an argument that it even ignores, and the only thing it uses is its argument. So there is nothing that actually requires this to be a local definition, okay? And when you think about what to make a local definition, there's I would say at least 3 checkboxes that you can think about, right? Does it require some local information that's not available globally, right? Is it really simple, right? So if it requires some extra information, then you need to make it local. If it's really simple, then you can make it local. And the third thing that I would ask myself is, does this function make sense outside of this function where I'm using it?
Wait, join class. I'll call you back in 2 minutes.
Say hi. Where was I? So the third question is, does it make sense to define it as a global function, right? Now that we have the means to define local functions, does it make sense to put it outside? And in this case, I would argue this function doesn't really make sense outside. It gets rid of one of its arguments for some reason and adds one to its second one. So it's not really meaningful. So this is actually a good example, I would argue, where it's simple, while it doesn't require any information that's inside of here, it also doesn't make any sense outside of this, right? So, okay, any other questions? All right. So there's some more stuff that I wanted to go through, but we'll start with it on Wednesday. Thanks for coming. Thanks for listening. Sorry for going over by a few minutes. Don't worry, Disha. Thanks. Have a good one. Oh yeah. Let me stop the.